So let's kind of talk through this. Ready? Oh, yep, we're off to a good start. Okay, so let's talk through this. Ready? This isn't on your paper. This is just, you were supposed to write it down. Okay, so if we're going to solve this, what do we need to do on this left-hand side? Distribute. So what's 8 times 4a?
32a.
Okay, 8 times -4?
30. -30.
Okay, is there anything I can combine on the left-hand side?
Oh, wait, that one.
Okay, so -32 and -1. That'll give me -33. And notice how I just copied the same thing on the right-hand side, like just brought it down. Now, when we solve, you want to think to yourself, I want variables on one side and I want numbers on the other. So you're trying to isolate the variable. You're trying to get it on an island by itself, right? So what we're going to do is we're going to move this -8 to the other side by adding it, because we're doing the opposite sign. Hey, yo, doing the opposite sign of what it is. So that's going to give me 40a minus 33 equals 14. Now we want to move this number to the other side by adding. And so that's going to give me 40a equals, 47. And then we want a by itself. So we're going to divide by 40 on both sides. Now this is going to give me an ugly fraction, but that's okay. So a is going to be equal to 47 over 40. Can you simplify that? It goes to a decimal, but can we like simplify the numbers as a fraction? I don't think so. I don't think anything is divisible by 47 and 40 that are the same. Okay. Do you need a second to try number 2? Or are you okay? Okay, I'm gonna give you a second to finish number 2 and then let's talk, because we got a lot to do today. So we're gonna multiply this guy. So this is gonna give me -32x. 4 times 5 is gonna give me 20. Again, we want our x's on one side and numbers on the other. So we're going to do the opposite of what the sign is. So this is negative. We're going to move this over here. So that's going to be plus 30. And so that's going to give me -2x plus 20 equals -26. Now we want x by itself, but it's attached to this 20. So we're going to do minus 20 on both sides. Hey guys. So this is going to give me -2x equals -46. When we divide by -2, that's going to give me x equals positive 23, because a negative divided by a negative gives me a positive. Cool, good job. Yeah. Okay, this should be fairly simple. This is setting us up for those linear inequalities, okay? So last year, you talked about linear inequalities in your 8th grade class. Like you've seen these before, okay? I'm going to try to make it as easy as possible for you, okay? It's a little tricky if you don't pay attention. So, we're trying to graph and interpret linear inequalities. What's an inequality? Do we know? It's a what? So what's an inequality? What word does it sound like?
Equal.
Kind of sounds like equal. Okay. Inequalities, you see these little symbols, right? What do these symbols mean? These little alligator signs. Greater, less than, those are the words that we use, right? Okay. So with that being said, okay, an inequality means that there are more than one correct answer. So if something is equal, it's absolute, guys. If something is equal, it is absolute. So it's x equals something. That's one solution. If I have an inequality, it means that there might be more than one solution that works. Okay, cool. So really quick, if I have this symbol right here with a line underneath, it's going to be a solid line. If I have no line underneath, it's going to be dashed. Okay, you got to remember that part. Okay. Okay. Over here, if I have this, I'm going to shade greater than the line. If I have this, I'm going to have less than the line. Okay. So here's an example. We got y is greater than 2x plus 4. Okay, so we're shading greater than. If I have a dashed line, so notice how there is no line underneath this little inequality, then I'm going to have a dashed line and I'm going to shade greater than or above that line. Okay, if I have this symbol right here, I'm going to shade less than or below the line. You know the difference between above and then below. Okay, cool. So then let's look down here. Oh, yes. Great. Okay. Technology is not my friend today. Maybe tomorrow. Here's how we can check. Like, if I've never been good at like memorizing those kind of things, so I always make sure that I pick a test point and then I check it. So for instance, let's take the point -3, 2. So let's take the point -3, 2, which is right here. Okay. And let's plug it in and see if it's a true statement. So watch what happens. We're going to plug in 2 for y, and we're going to plug in -3 into there. So we have 2 is less than or equal to 2 times -3 plus 4. So what we're going to do is simplify this. Well, what's 2 times -3? Okay. Yep. And then -6 plus 4? -2. Let's look at this statement really quick. Is 2 less than -2? No, so this is not a true statement. That means that we're going to shade away from that number. So notice how -3, 2 is right here. We're going to shade this way. So now we're going to test the point 0, 0. I want you to plug 0, 0 into this inequality, and I want you to check and see if it makes it a true statement. Remember, the alligator eats the bigger number. So for instance, 5 is bigger than 4. 6 is bigger than 2. So it always faces towards the bigger number. Okay, so take a moment, take 0, 0, plug it in, and check and see if it works. When you substitute this in, you're going to get 0 is less than or equal to 2 times 0 plus 4. Well, what's 2 times 0? And then 0 plus 4 is going to give me, okay, is 0 less than or equal to 4? Yeah, so that's why we shaded towards this point 0, 0, right? This is to check and see which way I want to shade. Okay, so you could pick a test point, you could plug it in, and then if it's a true statement, you're going to shade towards that side. Or you can memorize those little rules up at the top. I'm not a fan of memorizing more stuff. Now, sometimes we have this craziness where they want us to rearrange the equation into slope-intercept form. Remember, slope-intercept form we talked about last week, where we have y equals mx plus b, right? So what we're going to do is try to get that y by itself, okay? So our equation or our inequality right now is 2x minus 3y is less than 12. We want to get y by itself, okay? So we're trying to isolate y on its own. So we want to move this 2x to the other side. How do we move the 2x to the other side? We subtract 2x. Now, is y by itself yet? Is it attached to just, what's it attached to? That -3. Well, we're going to do the opposite of what's going on here. Multiplication's going on, so we're going to divide by -3. And when we divide by a negative number, inequalities are going to flip. When we divide by a negative number, inequalities are going to flip. That's going to give me 2/3 x and then -4. So how I got that was I took -2, divided it by -3. That got me this 2/3. And then 12 divided by -3, which is going to give me that -4. Okay, so now we're going to actually graph it. So let's ignore this inequality for just a second. What is my y-intercept in this? -4. What's our slope? Okay, so we're going to graph that. The first thing that you're going to do is you're going to plot your y-intercept. You told me it was -4, so I'm going to start at 0, 0. I'm going to go down to -4. 1, 2, 3, 4. I plotted my y-intercept. Now you told me that the slope is 2/3. That means I'm going to go up 2 to the right 3. And I'm just going to repeat that pattern. So I go up 2 to the right 3. Up 2 to the right 3. 1, 2, and it would be way over here. Okay. Now, is there a line underneath this inequality? No, which means that are we going to be a dashed line or a solid line? Look at your front of your paper if you're not sure. We're going to be a dashed line. Okay, so when you do like little dashes, you're going to leave a little bit of space in between. And then you want to make sure that you put arrows at the end. Okay, so it's going to be a broken line. And the reason why is because there's no line under the alligator mouth. Is that how you spell alligator? Alligator. Okay. So now we're going to decide whether we're going to shade up or we're going to shade down. Here's what I do. Again, I don't like memorizing things. I pick a point. Normally, I use 0, 0. So 0, 0 is right here, right? And that would be shading above. So we're going to test this theory. We're going to take this inequality and we're going to plug in 0, 0. So we've got 0 is greater than 2/3 times 0 minus 4. 2/3 times 0 is what? And 0 minus 4 is 0 bigger than -4? Yes. That means that we're going to shade towards it. So is that above or below? That's above the line. Okay, and again, if you want to memorize those, great, fabulous. You do you. But problem is with memorizing that stuff is you have to make sure that it's in this form before you start memorizing things. Another way you could have done this is Desmos does this for you. So if you're trash at graphing, that's okay. Desmos does it for you. Cool? Yeah. Okay. So Terrence wants to buy some movies on Blu-ray and some on DVD. Do you know what Blu-ray is? Okay, you don't know what DVDs are, right? Okay, thank God. Use the what? Speed racer. Makes sense. All right, the Blu-ray costs $10 each, and the DVDs cost $5 each. All right. So Blu-rays cost $10, DVDs cost $5. Terrence wants to spend no more than $100. So write an inequality to represent the situation for Blu-rays and DVDs. So really quick, right here, they told us what each variable represents. Okay, so they said that DVDs are your X's and Blu-rays are your Y's. That's really important. It matters which one is which. Okay, now, how much did they say each Blu-ray cost? $10. So we're going to say 10 times Y, bless you, And then how much were each DVD? 5. So we're going to say plus 5x. And how much money did we want to spend? No more than 100. So less than 100, right? So we're going to say less than, and we're going to say equal to, because we can spend up to $100. So we see how I put that together. I said, how much is each item? Multiply it times that variable, and then no more than 100. Can you take a moment? Can you see if you can graph this guy? You've got to rewrite it in that y equals mx plus b format, right? So you got to solve for y before you can do anything. So we want to get y by itself. We're going to move that 5x to the other side by doing the opposite sign. So it's positive right now, so we're going to make it negative by subtracting it, right? So that's going to give me 10y is less than or equal to negative 5x plus 100. Now, we're still trying to get y by itself. So we're going to divide by 10. And when we do that, we're going to get y is less than or equal to negative 5 divided by 10 is going to give us negative 1/2. Okay. 100 divided by 10 is going to give me 10. Now I'm going to graph this one. So remember, we always start with our y-intercept. So it's going to give me 10 right here. And we're going to go down 1 over 2. And we're going to repeat that process until we run out of space. Is it a dashed or solid line? It's a, if there is a line underneath, it's solid, right? So we're going to make a solid line right here. Hey, baby. Now, do we shade above or below? Okay, so let's check. Let's check and make sure. Okay, let's take that 0.00, right? And let's plug it in. So if we have 0 is less than or equal to negative 1/2 times 0 plus 10. Well, what's negative 1/2 times 0? So that's going to be 0 is less than or equal to 0 plus 10. What's 0 plus 10? Is 10 bigger than 0? Yes. So we're going to shade towards this guy. So which would you rather ride? Look at the board. Look at the board. Which would you rather ride? The one on the left or the one on the right?
The right.
Okay, raise your hand for the left. Raise your hand for the right. Yeah, me too. Okay. The left one is definitely safe. Definitely safe. Okay. So the Gwinnett Fair is in town. All right. Man, y'all real talkative. Okay. The Gwinnett Fair is in town, and you and your friends decide to meet at the fair this weekend. You have earned $50 from math tutoring available to spend. Each ride costs $3 and each game costs $2. How many rides can you ride and how many games can you play? Okay, so really quick, what I want you to do is sort your possible combinations from above based on whether they will save you money or not and spend exactly $50. So I want you to fill in that table, and your combination is going to be either like you can do 2 games, 5 games, etc. But you have to make sure that you spend either up to $50 or less than $50. Does that make sense? Okay, so you and your people at your group, y'all are working through this. I'm going to set a 15-minute timer, and I want you to work through part 1 and part 2. Okay? All right, ready? Go ahead. What did you notice? All right, ready? What did you notice about all the combinations where you spent $50 or less? What did you notice? Is there any pattern that you found? Based on your visual, what is another combination you think would work? How easily could you represent all these combinations? So, how did you write out a rule? What was your rule that you came up with for part 3? is the crickets for me. Okay, so what were some of the points that you came up with?
Which one?
So for the little table, what did you come up with? What? 5 and 2. So it was 5 rides and 2 games. How much are 2 rides and 5 games?
Oh, wait, no, that's.
JK again. Okay. 5 rides and 2 games. Okay, so how much are rides?
$3.
Okay. And then how much are games? Okay, so when you multiplied this, you got 15 and 2 times 2 is 4, so that gave me $19. So I could spend more, right? Did anybody get $50?
Yeah.
How much? What was the combination? 10 and 10. So we did 30 plus 20, that gave us $50, right? Did anybody else get 50? Yep.
6 and 16.
6 and then 16.
And 0 and 5.
So 3 times 6 gave me 18, and then 16 times 2 gave me 32. And then when I add that together, that gave me 50. Okay, and what was your other one, babe?
0 and 25.
0 and 25. So 2 times 25, and that gave me 50, right? And if you like saved up $50 and you're gonna go like ride a bunch of rides, you would definitely want to like maximize your time there, right? Like you wouldn't show up and just be like, all right, I'm gonna ride one ride and go home, right? Like that would suck. So how did you go about solving that? Like how did you find these? Like,
Oh,
sorry.
I did 2 plus 2 plus 2.
Okay, so you counted how many times like over and over again. Okay. So you told me that each ride costs $3 and then each game costs $2. And how much could we spend in total? But when y'all graph these, when you graphed it, you should have graphed these points and you would have seen this equation, or I'm sorry, this inequality kind of show up. Yeah. So it looks like this, right? All of these little points that we found fall in this little realm. So we got 5, 2, 10, 10, 6, 16, 20, 0, 25. All of those fall in this little shaded region. Okay. Now, if they are on the solid line, then that means that they're in an included point. Okay, so they're part of the solution. If this was a dash line, you could not find a solution on that line. The unshaded region represents all the points that do not make the inequality true. So we wrote out our equation, or our inequality. Okay. So we're going to switch gears. We're going to go to that last paper that you picked up. All right, go ahead and take a moment. See which one of these ordered pairs makes it equal to or great, I'm sorry. Decide if the values make the value of the expression less than, greater than, or equal to 12. So you're going to take this guy and plug these in and see if it's greater than, less than, or equal to. Okay, take a moment, try those. Okay, ready? So let's check your work. Ready? Okay, we took this point and we plugged it into this equation. Hey, yo. Okay, we plug this in. We're going to get 2 times 0 plus 3 times 5. What's 2 times 0? And then 3 times 5? 15. Cool. 0 plus 15 gives me, okay, is 15 less than, greater than, or equal to? 12. Greater than. So you're going to say 15 is greater than 12. Gucci. Okay. Look at the next one. If I plug in 6 comma 0, I get 2 times 6 plus 3 times 0. What's 2 times 6? 12. 12 plus 0 is going to give me 12. Is 12 greater than, less than, or equal to 12? equal to. Next one. -1, -1. I get 2 times -1 plus 3 times -1. When I multiply that out, I'm going to get -2 minus 3. That gives me -5. Is -5 greater than, less than, or equal to? Less than 12. The last one, 2 times -5 plus 3 times 10. When I multiply that out, I'm going to get -10 plus 30, which is going to give me 20. Is 20 bigger than, less than, or equal to? Greater than. Yay. So my neighbor is worried about the work. Oh, ready? Okay, my neighbor is worried about the work needed to maintain a grass lawn and flower beds. So she's looking at some low maintenance materials to use in her yard instead. Okay. By the way, when you buy your house, they don't tell you how much work like yard work is. And then like you have to do that like every like week or so, maybe every 2 weeks. It sucks. I don't like adulting. Anyways, moral of the story. She is considering artificial turf, which costs $15 per square foot to install, and gravel, which costs $3 per square foot. She may use combination of the two materials in different parts of the yard, and her budget is $3,000. She needs my help to figure out how much of artificial turf and gravel she can afford. To help her pay for her new outdoor renovation, my neighbor sells jewelry at a Saturday market. She makes $9 profit on each necklace, and she sells and $5 profit on each bracelet. Okay, so we got some lady who is trying to purchase stuff for her yard, and she is, making sure that she has the money by working, and this is the stuff that helps her make that money. Okay, so let's talk through this. On that first part, can we write an inequality just based off of this scenario? Yeah? Maybe? Yes? Okay, so really quick, we have artificial turf. We're going to call this guy X. And then we have gravel. We're going to call this guy Y. Now, whenever you see per, that means that it's probably going to be a multiplication problem, right? It's going to have something with multiplication in it. So $15 times the artificial turf plus how much is it for the gravel? $3. So we're going to say 3Y. And how much money can we spend up to? 3,000. Now, is that going to be less than 3,000 or greater than 3,000 or equal to? False. Less than or equal to. Because we could spend less than $3,000, right? We could save money. That would be okay. But we cannot spend more than 3,000. I need you to be confident in writing these inequalities. I need you to be confident in writing these inequalities because it's going to be on your midterm and it's going to be on your final exam. Okay? Can you look at the next part about the jewelry and can you write an inequality with that guy? So look at the next one and write an inequality. I see a lot of people on their phones. I need y'all tighten up. Let's go. Write an inequality on the next slide. Unfortunately. So, what did you come up with? I'm hearing a lot of mumbling. What did you come up with? So for a necklace, how much is it gonna cost? 9x. And then how much is it gonna cost for a bracelet? 5y. Now how much money does she need to make? Do we not? She needs to make at least $3,000, right? She could make more. Greater than or equal to 3,000, right? We know she's got a budget of $3,000, right? So she would have to like fund that $3,000. Now we're not taking into consideration that homegirl probably already has money, right? Yeah. Okay. So really quick, we're gonna do this little sticky bar thing. So I want you to read over the scenario. I'm gonna give you a sticky note. Okay, and I want you to figure out which one of these graphs is representative of this situation. Okay, so write the cost constraints. So you're going to write an inequality and you're going to graph it. Does that make sense? So you're writing the inequality and then you're figuring out which graph this is.